So the first PowerPoint here is all about the way that the human eye sees light and color and perceives the world in a different way than photographic materials or cameras. So in traditional photographic processes, analog material, you would have an image that's created in the negative that is a reversal of what you see in the real world. And then that is contact printed or printed through an enlarger and reversed into the photographic print. Digital cameras, on the other hand, store up an electric charge. Charge is essentially measured by a computer that then figures out how bright a pixel should be, and the computer puts the picture back together in the computer, essentially. The human eye is made up of different types of sensing materials, cones, which are only in the center of the back of your eye, called the fovea, versus rods, which are kind of more your peripheral vision, your night vision, and cones are what give you color and sharpness. So basically, what you're focusing on is what you're seeing in the cone, and then rods are kind of everything else. It's a lot what allows you to really have night vision, but it's also peripheral, so it's not focused. And so in photography, we use the three different colors that the eye senses mainly, or has sensors for, which is red, green, blue. So that's our primary colors in our color wheel. I'll get into this deeper later, but you also see yellow, magenta, and cyan, which are the sort of secondary colors. An important note is here that the human eye can detect 2.3 to 10 million colors, and a camera and a computer can handle much less, a camera much less, and then a printer even smaller size. And depending on how you're having things printed, they have more or less color, which we'll dive into at a different time. When it comes to seeing color, if you were out in a snowy landscape like one of these, you would probably not see the snow as being very, very blue on the left one, or being kind of red-orange on the right. So we can think about what should be the correct color versus what color can do to help generate more content in the image. So this is an example of what a photo might be originally like versus what it might be color corrected to be like. And so for the beginning of this class, I want you to focus on representing things accurately the way that it would technically be correct. So for example, on the right one, that one would be technically more correct, representing a gray road as as gray. Yeah. Whereas on the left one, that kind of creates a different mood to have the whole scene be very yellow. So we'll kind of dive into those sort of more mood generating options later in the semester, but for now, focus on what would be technically correct. All right, so optical illusions. Here's a couple different optical illusions. So for example, is this a cube that is flat on the bottom, or is it tipped up and to the left on the bottom? And then here is a different optical illusion where you don't typically, because of the sort of reference point of A versus B, the squares, you don't think of them as being the same shade of gray, but if you were to actually draw a line up through the middle of them, on the right you can see they are. It's just that the context to them is giving them different meaning. So after you've watched this PowerPoint, I normally at this point would play this Beau Lotto Art TED Talk, but I'm gonna let you do that after you've watched this whole video. But that's all about perception. It's a TED Talk, so it's under 20 minutes, but it's really interesting kind of the way that your eye can be fooled and how we rely on color to see things, and there's kind of a technology component to it that I think is really interesting if anyone is interested in art and technology being combined together. And so the whole idea of this is that your reference point for optical illusions can really depend on how you see it. So I normally play this and I get a good ground, or show this and get a good ground. Is it a blue and black dress or yellow and white dress, I usually get a groan, so I'll just skip over and move on. So here's some other ways that the human eye is different than the camera. So cameras have apertures, actual mechanical opening and closing parts to let in more and less light. Your eye has a similar, you know, if you've ever, you get a light shine in your eye, or if you ever go to the eye doctor, you get the droplet, you know, the eye drops that make you dilate. And so your eye is much larger. So you notice that. There are other ways your eyes can have a large but I won't dive into those right now. But the dynamic range, which is the difference between the brightest thing that can be seen and the darkest thing that can be seen, is probably the most significant difference between the human eye versus a camera. So the human eye can see a essentially contrast difference of 1 to 1 billion. So that's quite a lot. Whereas a camera is going to be measured in stops. So I should cover what a stop means. A stop is a halving or doubling of light. So if you have, when we get down to it, we'll be talking about aperture, shutter speed, and ISO, and those are all measured in halving or doubling by a stop. Anyway, so the human eye has capability to see 30 stops, which is really huge, but only about 15 stops at one time. And then cameras are only about 10 to 12 stops, but only about 5 to 9 stops at one time. So when you think about a really bright sunny day, that's when you'll see really heavy shadows, right? Now, human eye, you can see in the shadows, you can see in the bright areas, but a camera might not be able to capture that difference in contrast, or it might be hard to pull out the detail. I gotta say, from 20 years ago when I got my first digital camera to now, the difference is huge. It's really significantly different. Back then, the number of stops were probably like, I don't know, 4 stops max or something like that. I'm killing you with lots of technical info. I'm gonna move on. So here's a visual example of what that might look like. So there's this canyon, and the light is shooting in through the canyon, or you see the light up top. So you might be able to, with a camera, only capture what is seen on the left image or what is seen on the right image. And just, this is a copy out of a book. So just understand that this yellow section, let me see if my cursor will record, this yellow section up to the top on the right image is supposed to be blown out. It's just completely white, okay? And so you can either capture the foreground or you can capture that beautiful blue sky, but you can't capture them at once. Whereas with your human eye, you'd be able to see all that, okay? So that sums up this, this lecture. I hope you get some good info out of it, and remember to go watch the TED Talk, which should be right underneath the slideshow in the D2L system.